record, and please, Vassiliki, go ahead. The floor is
Sylvia, can you see the presentation clearly? Sylvia?
Yes, I can see it.
Okay, you can see the full screen, right?
I mean, now that I see, no, not everything. I think that you have to put less percentage because otherwise it's cut.
Um, Let me see. Is that better?
Like that is perfect. We can see everything.
Okay, let me do 35.
So keep it like at 30, 35% is perfect. Yes.
Is that okay?
Yes, it's okay.
Okay,
You can proceed. Thank you.
thank you. Okay, so give me a minute. Okay, good morning, everyone. Thank you for coming back. In our last session, we talked about, can you hear me? Okay. We talked about the why SmartLabs exist, what problem they solve, and what entrepreneurship means in the Pulse context. Today we get practical. Unit 3.2 is about one thing, turning an empty room into a functioning smart lab. Space equipment, furniture, budget, staff, safety. Basically the real decisions you will have to make. This unit can feel overwhelming because there are many decisions to make, but my goal is to simplify it. So by the end of this session, you will be able to look at your institution and know where to start. So let's go. The video of this unit covered 6 objectives. Rather than going through each one, let me tell you the single most important output. By the end of this unit, you will produce a draft equipment and space plan for your institution. A real document based on your actual space, your actual budget, and your students. Everything in this unit, the space assessment, the equipment, the budget, feeds into that plan. So keep that output in mind throughout this live session. Every decision we discuss today is a decision you will make in your plan. So, before we talk about the equipment, I want to make one point because it shapes every decision that follows. Your smart lab space is not just a room. So the way your space looks, the equipment you choose, how it is laid out, and how clean and organized it is communicates something to every student who walks in. If the space is thoughtful and well equipped, the message is your ideas are worth taking seriously here. So if the space is an afterthought, old furniture, equipment no one knows how to use, the message is the opposite. So think about a learning space that inspired you as a student or as a professional, and what made that space feel different. That is what you're trying to create for your students. So keep that in mind every time you make a physical decision about your smart lab. A smart lab is not one space serving one purpose, as we have already discussed. It has 3 functional zones, and you need to plan for all 3, even if you cannot build all 3 at once. The first one is a training space for workshops, classes, presentations with flexible seating, display screens, and collaboration tools. The second one is a makerspace for building and prototyping, workbenches, equipment, material storage, and of course, strong electrical infrastructure. And the last one is the incubation hub for mentoring and for project management and development. A more professional, comfortable environment with small meeting areas, whiteboards, and video conferencing. The critical principle here is how you integrate all these three. This should not feel like separate rooms necessarily, but students should be able to move naturally between learning a concept, then building something, then discussing it maybe with their mentor. So think about your institution. Do you have any space that could serve even one of these three functions? That is your starting point. You do not need to build all three zones simultaneously, but you can start with what you already have. The first step before buying anything, equipment-wise, is a rigorous assessment of the space you already have. And these are the 6 things you need to check. Dimensions, you can take photographs because you need to know exactly what you have before making any other decision. Electrical infrastructure, which is a critical constraint. Where are your power outlets? How many do you have? What is the strength, like the amperage, because some equipment requires more power than a standard office space provides. So find out before you buy equipment you cannot run. This is something to think about. Ventilation is also an important one because you need proper air extraction for some tools like laser cutting and certain fabrication processes. The connectivity, of course, Wi-Fi, etc. The flooring, because some equipment needs reinforced floors. Some areas need anti-static surfaces near electronics. And lastly, capacity, like how many students can actually work comfortably at the same time in your smart lab. The answer for a workshop and for a fabrication session is different. So my advice is before your next session, here, the next live session, to go to your space and document it. You can take photos, measurements, take notes on every constraint you find, and we can also discuss it. This is a part A documentation of your equipment and your actual space plan that you will have at the end of this module. So, if you have a choice between multiple possible spaces, these are 5 things to think about for your decision, for your final decision. Visibility is one. Choose a space that students can pass regularly. Visibility also creates curiosity and creates engagement with students. Proximity to resources, a smart lab that is near faculty offices and other learning spaces can create collaboration and better movement. Security, of course, because the equipment you will have will be valuable and you need access control, but also the space should be open, of course. And lastly, the expansion potential. If possible, choose a space with room to grow, because at first you maybe need a smaller space, but then if the smart lab grows, you need to have thought about expansion. So these are the decisions you will make once, and you will have to live with them. So you always need to think about the future also. So once you have your space, you need to design the internal layout. And these are 5 principles to think about. You need to think about zoning by activity type. Separate loud activities from quiet ones. Clear circulation paths. People need to be able to move through the space without obstruction, and this is also a safety requirement in case of an emergency. You also need sidelines for supervision. A single SmartLab manager should be able to see the full space from one position. Flexibility. The furniture you choose must allow rapid reconfiguration of a space. And lastly, a welcoming entry. The moment a student walks in, they should understand what the space is for. You can post on the walls SmartLabs purpose, make it feel alive in many ways. So this is a reference model that we have chosen to showcase the Fab Foundation's ideal laboratory layout. Of course, this is not what we will replicate here, but it is just a reference. What it shows is the full range of functional areas a mature SmartLab might have, from 3D printing to laser cutting, CNC routing, computer stations, electronics, and storage. The practical lesson here is about phasing. You do not build everything at once. You need to start with 2-3 areas, the ones most relevant to your own VET program. And then you can add others as your budget or student demand grows. So looking at this list, I invite you to think about what areas feel most relevant to the programs your students are studying. This is what you should think about. This is your starting point, your students' learning needs, and not just this catalog, right? Think about what your students would benefit most from. So let me go through the key workstations briefly. These are the practical requirements you need to know. 3D printing is typically the best starting point for most SmartLabs. The equipment is relatively affordable, safety requirements are manageable, and the impact on students is immediate and visible because they have a physical object at the end of the process. And this is a powerful moment. What you need is a minimum of 15 to 20 square meters of space, resistant tables, ventilation for fumes, of course, and a stable temperature because fluctuations affect print quality. You also need organization. Establish a sign-up system for machine use, inventory tracking, and workflow instructions posted clearly at each machine that will be used. If you're starting with limited budget, as I know you are, I would suggest to start here because a 3D printing area can be established with modest investment and can be used with high pedagogical impact. So another workstation is the laser cutting space, and is one of the most versatile and popular tools, as many of you may know. But of course, it requires more careful planning than 3D printing. So the first one, the very important thing is ventilation, because laser cutting produces harmful fumes, depending also on the material that's being cut. So ventilation is something to think about. You also need fire safety, so you may need smoke detection, fire extinguishers. Of course, you need training, so no student should operate a laser cutter without training. This is something to build in your own curriculum in the SmartLab for every person that will use a laser cutter. And of course, maintenance, right? You need the lens cleaning, calibration. Um, this is something that you can build in the calendar of the SmartLab. Another one is the CNC router space, and it's the most demanding workstation to integrate. It needs the most floor space and the most the most safety infrastructure, and of course supervision. So you need someone to supervise every process. You need minimum 30 to 35 square meters, mandatory supervision, as I mentioned. You also need material handling, which is a particular challenge because you need space to store and load the materials. If you're starting with a limited budget, I would suggest to defer the CNC router and start with 3D printing and laser cutting as your starting point. Then you can move on. So, the electronics workspace is one of the most versatile areas in a SmartLab, particularly valuable for your vet centers, especially the ones that have engineering, mechatronics, or IT programs in their curriculum. Some key requirements is, of course, separation from dust generating machines, bright shadow-free lighting for working with small components, ESD protection, anti-static floor matting, and ESD safe works surfaces, and grounding equipment. This protects both students and the sensitive components. Create a comprehensive inventory system for electronic components from the first day. So, this zone, the conference and co-working space, is the most usually the most underplanned, and it is a mistake because it is where mentoring happens, where ideas are pitched, and where teams come together. What you need are tables for around 10 people that can be reconfigured. So you need flexible seating for workshops also, and quiet coaching stations for individual mentoring. Whiteboards, ideally on multiple walls, and presentation capability for student pages. The design qualities that matter here are adaptability, comfort, and inspiration. This zone should feel separate from a classroom, should feel different. And one idea is that you can display, for example, student project work. So also other incoming students can see the work being done. And it also validates the efforts of the students who are participants. So, 4 infrastructure basics that are easy to overlook and may be expensive to fix in the long run. The first one is electrical supply. Each major machine should have a dedicated outlet. So think about whether you already have the electric infrastructure. Can you hear me?
أها
Okay.
أيوة
Okay. Do you want to say
ها
something? Did you want to say something? Okay. So another one is lighting, network connectivity with a stable Wi-Fi connection, and flooring. Build more electrical and network capacity than you currently need because your SmartLab will evolve through time. So now the equipment decisions themselves. 4 principles that should guide every purchase that you will make. You should be able to assess whether each purchase aligns with your program. This is very important because you should always start from your educational purpose, right? You should also prioritize versatility. You need equipment that serves multiple purposes and project types. The total cost of ownership, because especially machines are not something you just buy once. You need money for maintenance, for consumables, etc. And the most important one is start modest and then expand. Um, you need to start with the foundational equipment and then understand what your students actually need and move on from there. So, for essential equipment, categories for any smart lab. First one is the digital fabrication, which is 3D printers, laser cutters, eventually CNC routers if it's necessary, electronics and prototyping, so soldering stations, power supplies, which is essential for any engineering or technology program. Hand tools and woodworking, this category is consistently undervalued. And lastly, computers and software. Design workstations with adequate specifications for CAD software, collaboration platforms, and business planning tools. When selecting within each category, start with the most broadly applicable tool in the category. Pulse recommends a reference budget of 7,000 per institution. So let me walk through this budget quickly as a reference and something for you to think about. So we have the computers and laptops, which is around 2,000 euros. The printer, which is 300, projector and screens, 800, furniture, 1,200 euros, prototyping material, 500, cameras and recordings, 500, and lastly, the VR headsets and content, which is 1,800 euros. I would like to know, looking at this budget, is there anything here that you think would be particularly difficult to source or fund in your context? Or is it mostly possible? So moving forward to furniture. Furniture is one of the most important decisions you will make. You need good furniture, and for that, this is good furniture is characterized by adjustability. So maybe you need adjustable tables for different heights, for different uses. Durability, of course, because in a smart lab, furniture may take beatings, so you need good quality furniture. Mobility. Most furniture should be able to move with wheels, so you are able to change the space in a few minutes. And of course, storage integration. If the furniture has built-in storage, that's a plus, right? More space. So beyond function, your smart lab should feel like a place people want to be in. So 5 elements that make a space inviting is lighting, color, plants, inspiration, and lastly, comfort. And of course, maintaining organization, because a daily reset routine establishes professional standards from the beginning. One of the most practical decisions you will make is how equipment and tools are displayed. The principle is simple. If students cannot see the tools, they usually don't use them. So you need to display most of the equipment in open shelving. Use transparent containers if you can, and place the tools students use most in the most accessible positions. If something is less used, then you can put that in secondary areas. You can also use signs as a teaching tool, QR codes or instruction cards on how to use each machine or each tool. And the goal is a space where a student can walk in, identify what they need and what is available, find instructions on how to use something, and get to work without needing a staff member always behind them to help them, right? Of course, equipment is only as useful as the materials available to use with. So 3 practical points is to know your suppliers. You should identify local, regional, or even international suppliers for your key materials. Manage your stock. Implement a simple inventory tracking system from the beginning. And streamline procurement. Work with administration to establish a purchasing pathway for your most basic materials. You can create a spreadsheet with your materials list when you need to reorder it, and your contacts for supplying those materials. So in SmartLab, the human infrastructure is also very important. So we have chosen 4 roles that you should be able to allocate from the start. The SmartLab manager, who is the strategic leadership, the head of program development, um, management, and administration. The maker champion, which is the internal advocate. This person will build community, will connect the SmartLab with external resources, and maintain the institutional energy. The technical guru, which is the hands-on expert, the person who manages equipment, maintenance, and technical instruction, and of course, safety compliance. And lastly, the residents, the volunteers, the interns, the extended team, basically. You do not need a full team from day one. We have separated the Smart Labs into 2 models. The first one is the startup one. In this one, you basically need 1 part-time manager, 1 part-time technician, and of course, a lot of volunteers. This is your minimum viable Smart Lab. And then we have the full operations model with a full-time director, 1 or 2 full-time technicians, a workshop coordinator, and etc. So you can start with a startup model and then move on with the full operations one. Once your space is equipped and staffed, you need operational workflows. We suggest to publish a weekly schedule containing every workshop, sessions, mentoring slots that are available. Have time for equipment maintenance into the calendar, and also for event creation, like showcase events, competitions, etc. Another important factor to think about is safety, because every student must receive safety orientation, especially if they use the machinery we talked about above. And this is something you can also create a certificate around. So, equipment decisions must connect to the people you are serving and the outcomes you are trying to achieve. Your primary audience is vet students, but your SmartLab can also serve faculty needing professional development, resources, alumni, of course, and etc. So for each group, you should define learning goals using the VOICE framework, which is very specific, observable, integrated, contextual, and evaluable. And have goals that you can measure. For example, a bad goal is to improve student entrepreneurship skills, whereas a good goal is, for example, that by the end of the second semester, 80% of your mechatronics students will have a prototype and tested electronic device using the SmartLab equipment. That is something you can actually measure, and you can investigate why it happened or didn't happen. The final operational discipline is assessment. 5 things to measure is student competence development, user satisfaction, curriculum integration, SmartLab utilization, and graduate outcomes. So the improvement cycle is 4 steps: collect data, analyze findings, implement changes, and reevaluate. So this is basically it. This unit's reflection exercise is one of your most substantial deliverables, and it comes with the foundation of your final action plan. I would suggest to try to do it, even if it's not obligatory. So in Unit 3.3, we move from the physical SmartLab to its institutional strategy. And how do you embed the SmartLab in your institution's governance, curriculum, and long-term plan? That is what comes next. Thank you for your time, and see you in Unit 3.3. I don't know if you have any questions or feedback or anything.
Thank you, Vassiliki, for the session. Someone is talking, I don't know who.
Not me.
Okay.
Maybe.
So thank you. I wanted to say thank you very much for the session. It was very interesting. And yes, again, if anyone wants to ask something, some clarification, please like raise your hand and feel free to ask. Otherwise, we can close and we can like just see each other next week for the following session if everything is clear. I believe that
Thank you, Mira.
everything is clear. So thanks a lot, Vassiliki. Thank you all. So see you next week at the same time. And yeah, thank you. Have a nice evening.
Thank
Bye.
you, everyone. See you next week. Bye-bye.
Bye. Bye. Bye.
Bye. Thank you.
Thank you.
Thank you. Bye.
Bye.
Thank you very much.